Okay, so I'm going over the chain rule product rule according to the worksheet from class. And I think it's helpful to start out by motivating this. Why are we learning this very technical skill of chain rule product rule? And to think about this, we have a maximization problem, which might represent a creative model that one of you have built. And why we're doing this is because we want to eventually be able to do comparative statics on the exogenous variables in the models that you build. And to do that, you need the skills to take the first order derivative of a model with generic functions like this rather than actual functional forms. So to do that, we of course set up our first order condition the same way we always do. So we look at this, we've got an optimization problem, we've got some benefits, we've got a cost, and we take the first order condition by taking the derivative of the entire payoff function with respect to our choice variable x. And when you approach one of these problems, it helps by orienting yourself to the actual model. So and figuring out when will we use the chain rule, when will we use the product rule, and to do that I go through and I underline all of the choice variables that I'm taking the derivative with respect to. And first I want to see, are there any terms, and a term is anything separated by a plus sign or minus sign. So this is a term that have two x's, and if they have two x's, I'm probably going to use the product rule. And so here again we have two x's, two choice variables in this term, so I'm probably going to use the product rule in both the first term and the second term in our optimization problem. And then I see our third term only has one choice variable, so we won't need to use the product rule there. Now will we need to use the chain rule? Well, that depends on if this is embedded inside a function of a function. So we see that x influences L, and I like to draw out what x is influencing all the way out, so that'll tell me how many chain rule links are going to be there. So we've got chain rule, we've got x influencing L, L influencing T, and T influencing F. So because of that, we're going to have 1, 2, 3 terms in our first order condition. And of course, we should do that throughout the whole thing. We see that x influences h, x influences g, x influences r. That's kind of a helpful way of setting up your problem. Okay, so product rule. First times the derivative of the second plus second times derivative of the first. So let's just do that. So let's write out the first. By first we mean we pick it up and we copy it exactly the way it is, rx. Times derivative of the second. Oh, and actually one thing that can help here is identifying your first and identifying your second. So this is the first term, it's a function of x, and this is our second term. And we can do that for both of our product rule. We've got first and second, and that will just help us organize our work. So we've got first times the derivative of the second, and the derivative of x is just 1, plus second, x, times the derivative of the first. And of course we're writing out our derivatives like this. It's representing partial derivatives. Derivative of r with respect to x. And of course anytime you see this notation, we've got the dependent variable in the numerator, the independent variable in the denominator, and that sets us up well to think of this as an elasticity in case we have any data that measures elasticity. Alright, so first times the derivative of the second plus second times the derivative of the first. We've just taken the derivative of this first term with respect to x. Now let's do that for the second term. So we have, I'm going to do that down here just to not run out of space. So plus first, let's pick it up and bring it down exactly the way it is, gxk, times derivative of the second. So that derivative, the derivative of this, is going to be the derivative of h with respect to x, plus second, we pick it up and pull it down exactly the way it is, times derivative of the first. So derivative of g with respect to x. Now, anytime we have this isn't wrong, but it's helpful sometimes to remind ourselves everything g is a function of. So we remember g is a function of x and k. And that'll just help us keep track of, for example, if we want to change k as an exogenous variable to see how our optimal choice of x responds to that, we'll know immediately which term k is inside. Okay, so we've taken derivative of this, derivative of this. Now we just have one more, so it's a minus sign in front of this. And chain rule, product rule, we know we're going to have 3 variable relationships, 1, 2, 3, that we need to take the derivative of and multiply them by one another. So we just start on the outside and work our way in. So derivative of f with respect to t, and derivative of t with respect to L, or times derivative of t with respect to L, times derivative of L with respect to x. That gets at our chain rule and product rule, and of course, taking a first order condition, we always have to end it by setting that all equal to 0. And that's the first problem.